All right, pre-algebra 1.3. We are now looking at equations. Okay, so an equation simply is going to take two expressions and set them equal. So what that means now is that an equation is going to contain an equal sign. Okay? What that indicates is that the expression on the left is equal or represents the same number as the expression on the right. So when your equation contains just numbers, it's either true or it's false. Okay? So consider the equation 14 plus 5 equals 9. Okay, it's just numbers. This is the left-hand side, right-hand side. So is this true? Does 14 plus 5 equal 9? And it does, so we would say this equation is true. If we have 10 plus 11 equals 30. Okay. We want to decide if this is true or false. Well, does 10 plus 11 in fact equal 30? 10 plus 11, if we were to add that, we would get 21. So the number on the left does not equal the number on the right. Okay, so we would put an X through it and say this is false, because the left doesn't equal the right. Okay, so when it's numbers, pretty easy to decide, okay, if it's true or if it's false. When we have a variable, you can't classify it as true or false because it's saying some number with an operation is equal to something else. Okay, so we consider it an open sentence. Okay, because it contains at least one variable. So you can take that variable and replace it with a number and then decide if it's true or false. Okay, so consider the equation x plus 7 equals 11. This is an open sentence. We have a variable. A variable represents a number. We don't know what number it represents, but it represents a number. So if I replace that number with that variable with 4, I can decide, is this a true statement or a false statement? Well, 4 plus 7 does equal 11, so we would say this was true. Okay? But if I replace x with, say, 5, right? 5 plus 7 is not 11, so we would say this one is false. So it's an open sentence because depending on what it equals, decides if it's true or false. Okay? Those are equations. So then, okay, when you have an equation with a variable, that open sentence, we can select replacement values for that variable. On the last one, I used 4 and I used 5. I could have used anything. Okay, so we have to look at a replacement set. And a replacement set is a set of numbers that we could use to replace our variable. Okay, so in order to find a solution for an open sentence, right? Solution is something that makes it a true statement. okay? So in order to find that solution, for the open sentence, you're going to take your replacement set and you're going to try every number in the replacement set and see which ones make it true and which ones make it false, okay? So then if it's a true statement, it would be a solution. If it's not a true statement, it's not a solution. If none of the set numbers in your replacement set work, then you would say there's no solution for the replacement set. Doesn't mean that there's not a solution, just in that set you're given. So if we want to solve the replacement set, and it's going to be in these kind of squiggly brackets, okay? So our replacement set is 2, 4, 6, and 8. These are the values our variable can be in the equation x plus 12 equals 9 plus 7, okay? Well, first, x plus 12 is going to equal, what's 9 plus 7, right? That's 16. So what you want to do is you're going to take these numbers and see. We're going to try 2, 4, 6, and 8. So 2 plus 12. Does that equal 16? Nope, that's false. That doesn't work. 4 plus 12. Does that equal 16? It does. Okay. What you're doing is you're taking these numbers in your replacement set and plugging them in for x and seeing if it works, makes a true statement or not. Okay, so we said 4 plus 12 equals 16. That's true. 6 plus 12. Does that equal 16? And it does not. That's false. And then 8 plus 12. Does that equal 16? Again, does not, so that is also false. So given this replacement set, we're going to say our solution equals 4. That's the number out of this set of numbers that makes our equation true. Okay, one more. So along with equations, we can also have inequalities. So an inequality is a way to compare, okay? So less than or equal to, greater than or equal to. And what these inequalities are is they open to the larger value and they point to the smaller value. Okay. So just with numbers, for example, right? We would say 2 is less than 4. So this is less than. With the little line, it means or equal to. This one would be greater than. And the little line is greater than or equal. Okay? So the equal work more when you have a variable. Okay? So we could say that x is greater than or equal to 2. So this means that x might be 2 or something bigger than that. Just the less than or greater than, you're not going to include that value itself. Okay? So we're going to solve the replacement set. 2, 4, 6, 8 again. On the inequality this time, y minus 1 is less than 6. Okay, so same thing. We're going to put all of these numbers in for y. We have 2, 4, 6, 8. And we're going to check all of them. Okay, so 2 minus 1, is that less than 6? Right, well 2 minus 1 is 3. And 3 is less than 6. So this is true. Okay, do the same thing with 4. 4 minus 1. 4 minus 1 is 5. Is 5 less than 6? Yeah, so that's true as well. Okay, check with 6. 6 minus 1. Is that less than 6? Whoops, this should have been a 3 here, not a 5. Sorry, still true. But 4 minus 1 is 3, not 5. Okay, then we get 6 minus 1 is 5. That's where our 5 is. Is 5 less than 6? And it is. So this is also true. Okay, we're going to check the last one. 8 minus 1. 8 minus 1 is 7. 7 is not less than 6. So we're going to say this is false. Okay, so then comes time to say what our solution is. And we're going to say that the solution is 2, 4, and 6, right? We're looking for all values in our replacement set that make it a true statement. Okay, so this finishes lesson 1.3.